everyone! In this simulation, we're going to investigate Newton's second law of motion in an accelerating rocket. Here you can see a rocket consisted of a launcher with a capsule on top. The launcher carries a lot of fuel. We can control the rate of the fuel burnt. The faster it burns its fuel, the greater the upward force. As the launcher burns its fuel, its mass decreases. The mass of the launcher without fuel is about 20 tons. We're going to use the slider to set the rate at which the launcher burns fuel to 1.5 tons per second. And now we will click play. Once the fuel burns out, you will see the capsule separating from the launcher, and it will continue its journey into space. Check the graph. Developing. So the capsule separates from the launcher and continues its journey into space. And here's the graph. The red curve represents the launcher, and the light curve represents the capsule. It is accelerating highly. However, the launcher is returning back to Earth, as you can see. Why does the launcher fall back to Earth? Yes, since gravity pulls it back down to the Earth, it doesn't have enough energy to escape from Earth's gravity. Now we will click Reset, and we will try to set the slider to different burn rates and fire the launcher a couple of times. We will start with 0.5 and let's click play. Why does the launcher not take off at first if the fuel is burning slowly? Yes, you are right, because the weight of the rocket is greater than the upward force provided by the rocket. Why does the launcher eventually take off? True, since the mass of the rocket decreases as fuel is being burnt. Eventually, the weight of the rocket is less than the upward force provided by the rocket, and at that point, the rocket takes off. Now we will try 2 tons per second. So we will set the slider to 2 tons per second. At what rate must fuel be burnt for the launcher to reach its greatest height? Yes, at the greatest rate, which is 2 tons per second. Since the faster it burns its fuel, the greater the upward force,